Hello and welcome to Module 8 in our Python series. Today we're going to be talking about file objects, and then we proceed to make our Tic-Tac-Toe project clickable using Visual Studio Code and Tkinter. So let's begin with our discussion on file objects. And before we talk about file objects, we need to talk a little bit about I/O or input-output. There's three types of I/O. There's TextIO, there's binary I/O, and there's raw I/O. Our discussion today is going to focus on TextIO. So what then is a file object? An object that belongs to any of these categories, that is, be it TextIO, binary I/O, or raw I/O, is referred to as a file object. File objects are also called streams. So you may see these terms used interchangeably in documentation that you read. Both file objects, or streams as they are called, use the I/O module in Python. So now let's see the capabilities of file objects. We could have file objects read only, we could have them write only, we could have them read and write to a file. We could also have them randomly access a file or sequentially access a file. What's the difference between random access and sequential access? Random access would allow us to directly access a particular position in the file, and sequential access, of course, as we have already figured out, is going from the beginning of the file to the middle and then the end. What allows us to do random access? And this is important. There is something called the file pointer, which when the file is first opened is at the beginning of the file. And then of course we can use a method to move that file pointer to a particular position in the file. We'll see how to do that later on in the discussion. Now moving on, let's talk about TextIO because that's the focus of our discussion for today. And TextIO or text streams expect as input strings and produce strings as well. Right? So we have string objects. The easiest way to create a text stream or a text file is using the open method. This is a simple exercise that we will do in order to familiarize ourselves with the open method. We need to create a new file called myfile.txt in the directory mentioned on your screens, and then using the print method, add this particular line of text to that file. So let's take a look at how the open method works. First of all, in Python, the open method has a return value. The return value is the file object. Okay, we can then store that file object in a variable, use that variable to read from or write to the file. There are two arguments that commonly are used with the open method. As you see on your screens, we have file name and we have mode, though it has to be stated that mode is not mandatory. The file name is mandatory because we need to specify the file from which we want to read text or to which we want to write text. If we don't specify the mode, as you see on your screens in modes, if mode is not specified, read only is assumed. The other modes are W for write only, A for appending to the file, and when we open the file in append mode, the file pointer is automatically positioned after the last character of text in our file, or the last text character in our file. We have R plus for reading and writing and W plus for writing and updating. Now that we know a bit about the open method, let's go ahead and do that simple exercise. So we need to go to Python, the shell that is, and if you don't happen to have a documents folder within your username, you can easily create that. So if you go to C drive, just follow the path mentioned there, C drive users directory, and then username. I'm going to be using my username, you can use yours, and then you will see I have a documents folder here. If you don't, right click anywhere, click new, then folder, and then of course change the name to documents. Once that is done, then you can proceed to do the exercise. So we just start with open. Open the file name C:// and this has to be within quotes / username. So my username, you can use yours, documents / myfile.txt. Now if I don't specify a mode, Python's going to assume that I'm opening this file for reading only. That's R, right? And I will get an error saying no such file or directory. So now let's change the mode. After the closing quotes, type in mode = W for write only. The return value is now the file object. So we can see that this is coming from the IO module. This is the class that contains the attributes that allow us to read and write to the file. This is the name of the file. This is the mode, and that's the encoding. What is encoding? We'll come to in a little while. So as I said, we can save this file object in a variable. Press the up arrow to access the previous command. Press the home button on your keyboard to go to the beginning of this command. And then just type in FD, just a variable name. FD for file descriptor. You can name it whatever you like. Make sure though that it's meaningful to what the variable represents. And now if you look at FD, you'll see the file object. Now that we have that, we can write to the file. What's the line of text we need to write? This text will be written to the file, myfile.txt. And of course, we've been asked to use the print method. So print this text will be written to the file, myfile.txt. Now what happens if I don't specify the file somewhere? This is going to print where? On screen, or technically what is known as standard output. So the screen is standard output, the keyboard is standard input. Now we don't want it to be written to the screen, right? So we specify here the file parameter, file = FD. Now one would expect, since I've executed the print statement, this line of text should be in my file. Let's go now and check. All we need to do is use Windows Explorer, follow the path to the file, C drive, users, username, documents. I can see the file is created, but it has 0 kilobytes. So if I open it, there's nothing in the file. Why is that? Think about when you use Word or Notepad or any other editor for that matter. When you do not click the save button, what happens? Or you don't click save on the menu, what happens? The next time you access the file, the changes are not reflected, right? So what's happening then when you click save in these editors? What happens is there is a method called the close method, which is called on that file, which results in the changes you made being physically written to disk. So if you don't click save, that close method is not called, and so the changes you make to the file are not physically written to disk. Though the file may be present, as you can see here in our directory. So we need to call the close method. So let's do that. We just say fd.close. And now if we go and look at that file, you will see it has 1 KB. Open the file and you will see the line of text. Now let's try opening this file in W+ mode. Do you think the text we have just now in the file will remain. Let's check it out. So here we'll say, instead of W, put in W plus. Press enter. And let's check Windows Explorer. You can see the size has gone back to 0. And if you open the file, there's nothing in the file. So when we open the file in W+, existing contents are erased. We can of course write something to the file. So let's do that. And then of course we need to call fd.close to make sure this is physically written to disk. What about opening in append mode? Now will the text we have written be available to us? Let's try. Mode equal to A. Let's write something else to the file. So I'm going to use the same print statement. Just press the up arrow, press the home button again. And let's say this is the second line of text that will be written to the file. And of course we need to call the close method to make sure it's physically written to disk. Let's go check that file out now. And you can see that with the append mode, my file pointer gets positioned here, and therefore the new line of text is added after the last character that was earlier present in the file. Right? Okay, now let's try opening it in R+ mode. That's read and write. Let's say R+. Can we just write something to the file? Let's try. Let's change this to, again if you press the home button you go to the beginning of the line. Let's change this to third line of text. Now let's close this file to make sure what we have printed is actually written physically to that file on disk. And then let's check the file. If I open the file now, you can see my text has gone totally awry. Why is that? When I opened in R+ mode, the file pointer was positioned here. And when I executed the print statement and of course closed the file, then the line of text overwrote what was present. So how do we avoid this when we open in R+ mode? And that brings us to the next part of our discussion, which is seek and tell. So we can use a seek method to go to a particular position in the file. The beginning of the file is indicated by number 0, current position by number 1, and end of file by the number 2. But with text files, we can seek only from the beginning of the file. We cannot go to any particular position from the current position, that is 1, or from the end of file. The only place we can use end of file is where we actually want to go to the end of file. We cannot seek backwards from the end of file, but we can go to the end of file. How? So here I can say, let me just reinstate these lines of text so that the text is not going awry. We'll open that file again in, let's say, W mode. So now we've erased everything in the file, and then let's use a print statement to print the lines of text. So this is the first one, print again. This is the second line, and then the third line. fd.close. Let's go and look at the file. and you have the 3 lines of text, right? So now that we have that, let's open it in R+ mode. So here we'll see, let's go to the point where we're opening the file and open this in R+. So now remember, the file pointers at the beginning. We want to go to the end of file, and we can use the seek method. fd.seek, go to the 0th byte from the end of file. What does this 201 mean? If you go to the file, 201 would indicate the number of bytes or number of characters of text that were written to the file. So if you count the number of characters including the space, you will see that there are 201 characters written. Right, so now that we are at the end of the file, we can print something. So let's add a print statement there. This is the 4th line of text that will be written to the file, comma, my file dot text, file equal to fd, and then fd dot close. So now if we go and, sorry, let's just do that again, fd dot close. So now if we go and look at the file, you can see we have the 4th line as well. So what did we do? We use seek to go to the 0th byte, but where? At the end of file. So this first parameter represents the number of bytes. We want to go to byte 0, but where? At the end of file. And so the file pointer is positioned there. And therefore our text gets added. Of course, as you already know, you could just open the file in append mode, which would automatically position the file pointer at the end of file. Let's work with seek a little more and with tell as well, so that you familiarize yourself with how those work. So now if I say open the file again in R+, I can ask for where the file pointer is positioned. fd.tell will tell me it's at 0, meaning the beginning of the file. Now I can say fd.seek 40 bytes from the beginning of the file. Remember, with a text file, I can only use 0 here. fd.tell, it will tell me I'm at the 40th byte. Now I want to see what that line of text is. How do I do that? So for that, we need to use the read method. Before we go to the read method, there's one important point we need to discuss, which is encoding. What is encoding? We know that computers only understand machine language as zeros and ones. We as humans can read text, right? So when writing to the disk, the strings of text or the text that we write is converted into zeros and ones or bytes, and that's written to the disk. And when reading from the disk, the bytes are converted back into text or strings. And that's what encoding is. Now Windows, as we saw, uses by default CP1252. Why is this important? Unix uses UTF-8. So if you're bringing files from an external source, for example JSON files, they are normally encoded using UTF-8. And if you want to work with those files on Windows and you don't specify the encoding parameter, then Windows will try to use CP1252, which will create a kind of a conflict because your files are encoded using UTF-8, and you may end up with some kind of errors. And therefore, it's recommended to specify encoding when opening text files always. Okay, it should be standard practice. So that's about encoding. Now coming to read. How do we read from the file? We can use a read method, we can use read line, and we can use read lines. The read method will read the entire file stream until the end of file. So let's now go and try to use that to read this file. What if I say here fd.read? You can see that I have the text read from the current position, 40 bytes from that starting position. Okay. If I say read again, where is the file pointer now? It's at the end of file. So if I say fd.read again, I get the empty quotes because I'm already at the end of file. There's nothing to read. We can seek and go to the beginning of the file. So fd.seek 0,0 and fd.read will show us the entire text. Now if you say fd.tell, you are at byte 276. That's the end of file. So now let's look at a different method of reading. We can also read the file one line at a time. Read line. Let's use seek again to go to the beginning of the file. So fd.seek 0,0. That takes us to the beginning. fd.read line will show us the first line of text. What happens if I say fd.read line again? I get the next line of text. Try fd.read line again. You get the third line and so on. Right? So that's one line at a time. And then we have another way of reading, which is read lines. So read lines is very similar to read, except that read lines returns a list. If you look closely, you will see that read returns a string. Right? You have an opening and a closing quote. But now we use read lines. So let's seek to the beginning of the file, fd.seek 0,0 fd.read lines, and you can see we have a list, right? And this can be used because you can store this list in a variable. So if you do a seek again, you go to the beginning and then you say list equal to fd.read lines, then you can access the first element of the list, will give you the first line of text, and st1 will give you the second line, and so on. Right? In case of read, so I'm going to do a seek to go back, and then I say fd.read, but I store that in a string. And then if we look at string, right, we have a continuous string. We can say string of 0. Remember, all strings are arrays. And we get the first character. Right, so the difference between read and read lines, as I said, one returns a list, that is read lines, which returns a list. And we have read that returns a string. An important point to remember is that it is recommended to use a with keyword when dealing with file objects, because with automatically closes the file, so we don't need to remember to call close on the file object. So let's now go and use the with keyword. I'm going to clear the screen. Hope you remember lambda. So clear equal to lambda No parameters going there. os.system CLS. Call the clear method. The screen is clear. So now let's use the with keyword. With open, and we need to specify the file name. So C:/users /username /documents /myfile.txt as, let's call it file disk. Okay, and then you can just say file disk dot read or read lines. Let's try read first. Right, so it's returned as a string. Now can I try to go to the beginning of the file? Let's see, file disk dot seek 0,0, and Python tells us you're trying to do an IO operation on a closed file. Right? Remember, the with keyword automatically closes the string or closes the file. And so we need to open it again. Let's now try to use the append mode and add some line of text. Mode equal to A. And then we'll use the print method again to write to the file. This is the 5th line written to the file, comma, file equal to file disk. Right. Now if we try to read from that file, let's use read line now. Let's take away mode. We don't need it, right? And say file disk dot read line. And so we get the first line of text. Can we say file disk dot read line again? No, because the file is closed. So how then do we read the lines? So what we can do is, we can say with open, and then we can say for line in file disk print line. Just simply that. And now you get all the lines of text. Okay. You could also use read lines. So now we could open that file again and then say file disk dot read lines. Right? And you have the entire text again, but in list format. So this is how you use the with keyword. Just remember that with keyword automatically closes the file, so we don't need to call the close method. Now we're moving on to string IO. We've looked at text IO. Now text streams or text files can also exist in memory. Okay, so a text stream uses an in-memory text buffer, right? So this buffer will be accessible as long as we don't call the close method. The moment we call the close method, that memory is released, right? So it's no longer available to us. We can set the initial value of that memory space using the parameter initial value, and we can use get value to return the contents of the buffer. So let's try this out. Let's try creating a text stream in memory. And if we just try to do something like this, let's call it tbuff, text buffer equal to IO. We've got to call string IO. But Python will tell us that IO is not defined. We need to import the module. Import IO, and then try that command again, and we have tbuff now. We can write something to this. Let's try writing string. So we can say t_buff dot write string. Okay, and then we can say t_buff dot get value, and you see the contents of that buffer. Okay, once you execute the close method on this buffer, it will no longer be available to us. Okay, so that's about string IO. If we look at the contents, or rather the type of tbuff, you can see it's a string IO object. Look at the type of file desk, and that has a different class. You can also see this as name, mode, encoding, etc. Whereas this just has a memory address. Okay. And again, like I said, as long as it's open, you can see the contents. Right? But call tbuff.close. And now if you try to access, you have the error IO operation on closed file. So now that memory has been released and is no longer available to us. Okay, so I hope that's clear. Moving on. We now need to install Visual Studio Code so that we can work with Tic-Tac-Toe to make it clickable. How do we do that? Simply just go to your browser and type in VS Code download. This is the official link. Click on the link. So now this is the official download page. If you're using Windows, you can use any of these to install, though I recommend you use System Installer. To find out the configuration of your machine, you can just type in system info, click open, and if you go down this list, you'll see system type. So mine is an x64 based PC, and therefore I can download the 64-bit version. If yours is x32, then you need to download the 32-bit version. As I said, use System Installer. So if you click on this now, you will get the file downloaded. Now if we go to the downloads folder, you will see here VS Code setup. Now if you click on that, you will see this particular screen, right? Accept the agreement. Of course, before this you will get the dialog box asking whether you want the software to make changes to your disk. Agree to that. Accept the agreement, and then you will see this screen. So just click on all of them because we need all these to work. Once that's done, Visual Studio will open up. Just close it. And now we'll start work with Tic-Tac-Toe and Visual Studio Code. Right? So, first of all, command prompt. Click Run as Administrator. Yes. Now we have the command prompt. We are in the System folder. CD / to exit. Type in dir, you'll see the contents. Now we need to go into the Users folder. You can create a folder called Python scripts. I'm going to go into Python scripts. What you do is you will type make directory mkdir Python scripts. Okay. Now it's telling me that I already have it existing. Right? Anyway, once you've created this directory, then you can change directory. So again, in the Windows command prompt, you can also use the up arrow to go to previous commands. So cd Python scripts. Now you're within the directory. You need to now create a workspace. Okay, so we'll make another directory. Make directory, you can call it Tic-Tac-Toe or something like that. Right? Then change directory to Tic-Tac-Toe. And from here, you can type in code space dot. Press enter. And that should load Visual Studio Code. Once Visual Studio Code is loaded, click on this Yes, I trust the authors. Now we need to indicate to Visual Studio Code that we are working in Python. So click on the extensions icon there and select Python. Now you will see I already have it installed, so Visual Studio Code is asking whether I want to disable or uninstall. You will see install here, just install the extension so that we can work with Python through Visual Studio Code. Once that is done, you can click on Explorer. Right, so you can start now by creating a new file. Call it Tic-Tac-Click or something like that, .py. Okay, to indicate it's a Python file. Press enter. And let me start by giving you a simple demonstration of how this works. So I can just say print hello world. Right? And now to execute this, just right click, click run Python file in terminal. See the terminal start up and you'll see our message. Right? So now we can proceed to create our file. Before we do that, there is one thing I need you to see. You don't need to do anything. I'm going to go into idle. So far, we've been running our files or our scripts from the shell in idle, right? So let me now open up one of the files that we created. Right, so let's take this one. So we've been running this like this, right? So we say run and then we call the function passing in a string and that gets converted. There's another way to do this. We could run this from inside the file. And so we can say convert to uppercase and pass in a string. Okay, so now if I run this, you can see that it ran directly. Now this is the format that Visual Studio Code follows. Anyway, now we need to start typing in our code. So what are the functions we need? We have one function where the users select their play piece. Then we have another one which will draw the grid, and since we're using Tkinter, we need to have the main window, we need button widgets, we need a function that will be executed when each of the buttons is clicked, right? That will be a common function for all buttons, of course, and that function will check whether the button clicked already has an X or an O in that position on the grid. We will also execute or call another function from this one which will check for a winner, and we also need to check if there are still empty spaces on the grid. So in effect, we'll have one function here, one function for drawing the grid, one function that will be executed when the button will click, and within that, of course, we'll call another function. So we have 4 functions. So now let's start with the first function, which is the selection of the play piece, and of course taking in the players' names. So def select play piece, and we start by asking player 1 their name, equal to input, please enter your name, comma, player 1. Let's leave a space there. Then you can also put in a colon. Then we ask player 1 to select their play piece. So play piece equal to input hello plus player 1 name plus please select your play piece X or O. Right? And of course you can leave a gap there as well. Now we need to ask player 2 to enter the name. So player 2 name equal to input please enter your name player 2. Right? Now player 2 doesn't need to choose their play piece. Remember, it's either X or O. So now we can check what play piece contains. If play piece equal to X, then we print hello plus player 2 name plus your play piece is O. Right? Else, and now we can copy the same line, Control C, and just paste it here, Control V, your play pieces X. So So this completes this function. Return ends the function. Next function we need to write is the DrawGrid function, and remember here we are using Tkinter. So we'll start by importing Tkinter. Import Tkinter, and you see Visual Studio gives you these clues, right? So, or cues rather. Import Tkinter as tk so that we can use tk when we are coding instead of using Tkinter. Now, using Tkinter, remember we need the main window, right? And of course we need buttons, right? So for buttons, remember this is going to be a two-dimensional array just as we did in the non-Tkinter tic-tac-toe. So let's initialize that list or the array btns equal to question mark for, now this is the column, in range 3, right? And then for x in range 3. It's a 3 by 3 grid. Okay, so we've initialized that. Now of course we need to have buttons placed like I said, but we need the main window first. So here we will say m window equal to tk dot tk. We are initializing a variable with the tk class, right? So that we have access to all the properties and methods of this tk class. So now we can use the property. We can say m window dot geometry. This is going to specify the dimensions of that window or the frame. So equal to, I'm going with 400 by 400. You can change these sizes and see how it looks on screen. And now it's time to use the button method. Okay, for the buttons. So for x in range 0, 3, and then for y in range 0, 3. Why do we need two loops? Because it's a two-dimensional list or two-dimensional array. Now that we've written DrawGrid, we can proceed and write the function ChangeText. Okay, so let's code that function now. Def ChangeText. And this function, remember, is going to be executed every time a button on the grid is clicked. So ChangeText is going to bring in the list and the row and column position of the button clicked. The first thing we need to do is check whether this button has already got an X or an O on it. And we can do that by saying if btns row and column position dot cget text. So here we are accessing the text value using the cget method equal to X. I could also have an O, so we got to check that. We'll just copy this, Control C and paste it here, or Control V and then equal to O. Then we just indicate to the player that the space is already taken. So print that space already taken. Try again. Okay. Elif. Now we need to know whether to place an X or an O on the button. But how do we know that? Right? We need to have an indicator of who's playing. So let's do one thing here. We will have flags. Let's call them player 1 flag. And we'll have player 2 flag. we'll initialize player 1 flag to Y and player 2 flag to N. And here we'll check if player 1 flag is equal to Y, and we need to know whether player 1's play piece is X or O, right? And play piece is equal to X, then we place an X on the button. So how do we do that? We say btns X Y. Now we use the config method. Config, and this is to set the text value. This is to access or get the text value, and this is to set it. Config text equal to X. Okay. Elif player 1 flag equal to Y, but the play piece is O, right? And play piece equal to O, then we need to place an O on the button, right? So btns X Y dot config text equal to O, right? Now we need to check whether it's player 2's flag that is a Y, right? So elif player 2 flag equal to Y and play piece equal to X, right? Then we place an X on the button. Dot config text equal to X, else player 2 flag will be Y, but play piece will be O. So btns X Y dot config text equal to O. Now I have a question. Where in our code in ChangeText is player 2's flag becoming Y? Right, so we need to do that somewhere. So what we'll do here is, after player 1 plays, and we place an X on the button, for example, then we say player 1 flag equal to N now, and player 2 flag equal to Y. And the same thing will go for this condition, right? Correct that indentation. And for player 2 now, when player 2 plays, we do the opposite. So here we'll say player 2 flag equal to N and player 1 flag equal to Y. And we'll do the same thing here. So we can just copy that down, Control C, and paste that here. Correct the indentation. Now you can see I have many of these yellow squigglies. Now why is that? And that's because we haven't defined these in this function. We define them here. So let's make them global. Global player 1 flag, comma, player 2 flag. right? But I still have the squigglies. Why do you think that is? Remember, when I am changing the value of these variables, because they are not defined in this function, they're declared global here, yes. But when I'm changing the value, I need to declare them global here as well. So global player 1 flag and then player 2 flag. Right? And that completes our ChangeText function. So we can put a return statement here. Now we need to code our CheckWinner function. Where is that function going to be called from? So we need to call CheckWinner whenever there's a play, be it player 1 or player 2. And to CheckWinner we will pass the list. Okay, so here we'll start CheckWinner. And of course the list is going to come in there. And we're going to check horizontally, vertically and diagonally to see whether we have a winner. Let's start with horizontally. For x in range 0, 3 and then for y in range 0, 3. Now for a horizontal win, there should be 3 contiguous x's in a row or 3 contiguous O's, right? So if btns x y, that row column, equal to x, right, then we should be counting those, right? So first time it could be 1, the next time it could be 2, or it could be just remaining at 1, right? So let's have an x counter here and we'll increment that by 1 every time an x is encountered. Okay. Elif btns x y. Now can I really do something like this equal to x? I'll have to use cget. So dot cget text equal to x, x counter plus equal to 1, and if btns xy dot cget text equal to O, then we'll have O counter increment by 1. Now of course we got to define these, therefore we have these squigglies. But where do we define them? Remember, within this inner loop, this is going to count basically up to 3, right? Because we have 3 columns in each row. And after this loop has finished, control is going to go here. For the next row, should x counter continue to increase 4, 5, 6, or should we initialize it to 0? And the answer is yes, we need to initialize that to 0 so that we can start counting again from 0 and then move up to 3. Now what if there are 3 x's in a row? So after we finish this loop, or after control comes out of this loop, having finished our range count, we can then check if x counter equal to 3. What does that mean? It means that we have a winner, right? So we can print we have a winner But who is the winner? Right, we need to check the play piece. So here, instead of directly printing, we say if play piece is equal to X, then the winner is player 1. Else, print the second player's name. Print we have a winner plus player 2 name. If O counter is equal to 3, then again we check the play piece. If play piece is equal to X, print we have a winner in the second player's name. Right? Otherwise, we print player 1's name. So print right. Now, if we have a winner, we have to get out of this particular function. So what we can do here is, when we have a winner, we can have another indicator. So winner X equal to Y. And if O counter is equal to 3, we can see winner O is equal to Y. We need to break out of this loop. We can say break here, and we can say break here as well. Now when we break out, we can check the value of these two indicators. And here we can check if winner X equal to Y or winner O equal to Y, then we can return. Otherwise, you got to check vertically. So else if buttons transposed equal to, and I hope you remember this, row of I, right, or row in BTNS, then for I in range 3. Here we'll say for X in range 0,3, and then for Y in range 0,3. But now we are using buttons transposed. The list, that is, we are not using the button list. If BTNS transposed X Y dot CGet text, right, is equal to X, then again we have X counter plus equal to 1. Right, elif BTNS transposed X Y dot CGet text equal to O, then O counter plus equal to 1. Now, of course, we've got to define these again, or rather initialize them again. So here we'll say X underscore counter equal to 0. So you can just put a comma there. O comma O underscore counter equal to 0, 0. Right, so every time a new row starts, they are initialized to 0. And then we check, of course, if x counter equal to 3, then again we have winner x equal to y, right? And then we check if play piece is equal to x, then print we have a winner. So actually we could just copy these lines here, Control C, and paste them here. Control V. They are, indentation has gone a bit out of whack, but we can correct that. What if O counter is equal to 3? So elif O counter is equal to 3, then we have winner O is equal to y, right? And then again we check. So we can copy this part now. Control C and bring that here. But again we need to check the indentation, right? So now we've taken care of if O counter is equal to 3. And again we can check if winner x is equal to y or winner O is equal to y, then we return. This should actually be indented less, right, because that has to be in line with our outer indent. Okay, remember this has to be in line with our outer for there. Okay, return, else we have to check diagonal. Remember we got to check the right diagonal and the left as well. So we start with the left one. So else we'll initialize x counter and O counter to 0, right? And then we say if the DNS of 0, 0, so we're doing the left diagonal first, dot cget text equal to x and btns of 1, 1 equal to x, and remember we got to check from the left right down to the right, extreme right I should say, so the rightmost column of the third row, right? This is the leftmost column of the first row, and btns 2, 2, right? If that is also equal to x, then we can initialize winner x equal to y, and we got to check play piece. So if play piece equal to x, then we print we have a winner plus player 1 name, right? Else print. Okay, this else is a bit awry, as you can see there. Right, so we're gonna write right from this point. And let's correct that. Now it's fine. So print, we have a winner plus player 2 name. Right? So now we finished with the left diagonal. Now we got to check the right diagonal. So elif, and I'm going to copy this down. Right? Hopefully things don't go awry there. So elif. Now we'll change these. So this will be in the first row. Now we'll have to go to the last column. So we change it to 2. Then the second row remains the same. But the last row, this should be first column. So if that is equal to x, then also winner x should be y. So winner underscore x equal to y. And then we check play piece. So if play piece is equal to x, right, then print, we have a winner, right, plus player 1 name. Else print, we have a winner player 2 name. So I'm just going to copy this now here, right? Now what about checking for O? So elif btns of 0 0. So we can take this whole line and then change the detail from X to O. Control C, right, and do a Control V here and change this to O. Right. So here we say winner underscore O equal to y. And then we check play piece again. If play piece equal to x, right, then print, we have a winner. So again you can copy this. Right, Control C and paste it here. Else print, we have a winner player 2 0, right? Right, elif, and now we can copy this line. Control C, Control V there, equal to X, then we see, or rather O, right? So we need to change that. Then we see here, winner underscore O is equal to Y. And then check play piece is equal to X. Then we should print the second player's name, right? So print we have a winner plus player 2 name, right? Else print we have a winner plus player 1 name. Right, so now we've taken care of the diagonal. So now if we don't have winners vertically, horizontally or diagonally, then play has to continue, right? But we need to check that there are blank spaces. So let's have a blanks left variable equal to n, and then in a loop we check for x in range 0, 3, for y in range 0, 3. And then we check if btns x y dot cget text not equal to x, and we got to check that it's not equal to O as well. So btns x y dot cget text not equal to O, right? Then what we do is we'll say blanks left equal to y, and then we can break out of this loop. If blanks left equal to n, then we can just exit. Okay, so sys dot exit. Right, now we're getting this squiggly because we need to import sys somewhere, but we'll do that when we are calling the functions. So here what we do is let's say import sys, and then we'll call the functions. So the functions are and DrawGrid. We don't need to call anything else because we're calling those functions from within another function, right? Now we have 2 errors which we need to track, as you can see here. Okay, so I already see something here that is not valid. So here we need to say dot cget text, right? And again dot cget text here as well. So we can just copy that down instead of typing it again. Control C and put that in here. Control V and here as well. Control V and Control V here as well. And Control V. Okay. Now let's see what those errors are. So here we have an extra colon, which we don't need. Right, so now those errors have gone. Let's check our logic. There is one thing that we need to do. We have winner X and winner O, right? But we need to, in the beginning, have them initialized here. So here we'll say winner X, comma, winner O equal to n, comma, n. Okay, so let's run this now. Run. X, display. Okay, let's try again, and it says that space already taken, so that part of our code is working. Let's try O. Now it's only putting an X, right? So we have an error there. Bin this, and we go to check why that is happening. So that's in our ChangeText. So the second time we play, this is happening, which means that player 2 flag player 1 flag is equal to n, and player 2 flag is equal to y. So we will come right here, right? So here we are checking if player 2 flag equal to y and play piece is equal to x, then we are putting an x, right? So this is a problem. So we'll say here text equal to O, right? Otherwise, here we'll say text equal to x. Now let's run that. Okay, let's try that again. Try to place another letter there, doesn't work. Here now we have an O, right? Let's continue playing. Let's say O here, let's say X there, O here, X here, O there, X, and it exits. So we should have put in a message there saying no players, or no winners rather. So let's bin this terminal, and here we'll say in CheckWinner, that is, if blank left equal to no, print no winners for this game. Thanks for playing, right? And here we'll say blanks left equal to y. We can say print no winners yet, or no winner yet. Play will continue, right? Okay, now let's run this again. Let's select X. Let's say Sam. And now let's play another game. So you see now this is appearing 3 times. So why is that? If you see here, I've put the print statement within this inner loop, right? So we need to put it within the outer loop. So what we can do is, instead of putting it there, we can put an else here, right? Print, I'm just going to put a control V there, right? Just need to make sure the indentation is right. And then we can say return. I can put the return here because this is anyway exiting. Okay, so now let's run it. X. Right, let's play another game. Okay. O. So now you see this is appearing only once every time we play. X. Let's say O. And now we should have a winner, right? But we are not. Okay, so we need to check that. This is a diagonal. So where's our diagonal check? Here we are. So this is what we need to check. So here, as you can see, we are not using cget, and that is what is causing the problem. So you get text equal to x, and again here, right? Dot cget text. Okay. So now let's run it. Let's say X, and then O, the name. Let's try that once again. O, X, O, X. Now we have a winner. This is where we should end, right? So why is this not ending? And this is not ending because here in ChangeText we need to check. So we are ending the game if there are no blanks left, but we are not really ending if there is a winner. So here we'll say if winner X equal to Y, or winner O equal to Y, right? Then sys dot exit. And of course we can print a message there. Print thanks for playing. And exit. Right, now I'm getting squigglies here because these are not defined in this function. So what we can do is, where we define them, we declare them as global. Global winner X, comma, winner O. Right? Now let's run this. Chris, let's say it's using X, and Sam is O. So we have no winner. We will continue. O, no winner yet. Say X. Let's say O here, and then let's say X here, and O there, and then we have a winner. Right, so you see how this works. You can check this again and again, see if you find any bugs, and of course let me know. Right, so this ends our session for today. Next time we will work with the date time module, and we'll do a project using that module. Till then, take care, stay safe, bye.